Welcome to the Bentley Institute's staad Pro Generating Wind Loads training course. Over the next series of videos, we will demonstrate how to generate wind loads in staad Pro, including creating the wind load definition according to the ASCE 7 design standard, defining the wind load cases, and creating the wind load items. In this video, we will be discussing wind load cases and wind load items. After your wind load definition has been created for each of your global axis directions, you can then create your wind load cases and add your wind load items into each of those load cases. For this particular model, we will be generating 4 wind load cases that will be for our wind load in the positive and negative x directions, along with your wind load in your positive and negative z directions. To enter new wind load cases, we must first go to the correct location through the page control area. We will select the General tab, followed by the Load and Definition subtab. In the Load and Definition dialog, if we expanded the Definitions group and the Wind Definitions item, we can see that this model contains a wind load definition for windward, leeward, and sidewall wind pressures in both the global X and global Z axes directions. We are now ready to create our wind load cases, which will then use those wind definitions to identify the wind pressures. We'll expand the Load Case Details group, highlight it, and then click Add to create our new wind load case. This is a primary load case. We will leave it set to number 3, and we will enter our loading type. The loading type will become important later on if you plan to incorporate this load into the automatic load combination generators available in staad Pro. Of course, the loading type will instruct staad Pro what load combinations to include this load case in, and also what factors to apply to it. We will then create our wind load case for our positive X global axis direction, and then click Add. Before leaving this dialog, we will specify the other load cases that will be required for this particular structure. Those will be wind load in the negative X direction, wind load in the positive Z global axis direction, and wind load in the negative Z global axis direction. After the wind load cases are created, you can now add wind load items to those load cases. The wind load items will use your wind load definitions, and by entering the different parameters such as the type or the exposure or the factor to those wind definitions, you can instruct staad Pro on how to apply the wind load to the model. In addition, we also do have a toggle to define this as an open structure. Now, by default, staad Pro assumes that structures are enclosed, and it seeks out closed loops formed by framing members, and then generates panels or closed surfaces based on the members in the range specified and their end joints. The area within the closed surface is determined, and the proportion of this area for each node in the list is calculated. The open structure option does provide a way to indicate that the structure is not actually enclosed to catch the wind. If this option is selected, wind pressure will still be calculated and the load will be applied to the structure, but the loads will be based on the projected area of the individual framing members in the model, and they will be applied in the form of the line loads on the members instead of nodal loads at the joints. We are now ready to create our wind load items within each wind load case. We will first start with our wind load in the positive X global axis direction. So we will begin by selecting the appropriate load case and then clicking Add. In the Add New Load Items dialog, we will now select the wind load type. This load type would not have been available to us if we had not already entered a wind load definition for this model. The Select Type field instructs staad Pro which wind definition would be appropriate for wind in this direction. So we'll select Type 1. This was our windward force in our X global axis direction. We will identify it as a windward face, and we'll enter the factor. For here we will enter a factor of 1.0, and we will keep it positive, indicating that this is a force in the positive x global axis direction. After entering the appropriate parameters, we will then click Add. We will now proceed with this load items within this load case by adding some additional items to account for the leeward face and also the sidewalls. For the leeward wind load, that corresponds to our loading type 2. We will select -x and say it's a leeward load, and we'll keep the factor set to 1.0, again for the positive direction. Then we will click Add, and we'll add 2 more load items for the sidewalls. Our sidewall definition is number 3 for our x direction. We will select our -z leeward or sidewall face, and for the first sidewall we will enter a factor of 1.0. Click Add, and then we will also add an additional one with a factor of -1.0, and then we'll click Add. This concludes our load items within our wind load for our positive x global axis direction, so we will click Close at this time. We can now see that we've created 4 wind load items within the wind load case for wind load in the positive x global axis direction. These would represent your windward, your leeward, and your 2 sidewalls. If I select each of the load items, I can actually see that, again, this is wind in the positive x direction. Here's my windward face. There are the loads for my leeward face, and I have my 2 side walls. If I wanted to review the load values themselves, I could go up to my Structure toolbar and click on the Symbols and Labels icon and select the value for load values. Following the same procedure, we will now generate our wind load items for wind acting in the negative global x-axis direction. We will select our appropriate wind load and again click Add, and we'll select our wind load type. We will still use type 1 for our windward face and select that as our x windward force, but instead, to indicate the direction, we will give it a factor of -1 for this particular load case. We will do the same thing for our leeward force, again with a factor of -1. And then we will enter our 2 side walls. Now we can see that our leeward, that our wind in our negative global x-axis direction has been created for our windward, leeward, and 2 side walls. To complete this process, we will also generate wind load in our positive and negative z global axis direction. And we can see that load type 4, 5, and 6 are appropriate and have the correct parameters for the global z direction. Here for our windward face, we will select load type 4 and select the Z windward face. For the leeward, we will select load type 5. And our sidewalls, we will utilize our load definition number 6. And we will do the same process for our wind load in the negative Z global axis direction. After reviewing all of your wind load cases, we are now finished applying all of our wind loads to our model considering the requirements of the ASC 7-2002 design standard.